Hello and welcome back to part 5 of my EarthGames project. Of course, if you weren't aware, this is the second video on the same part, so I'd recommend watching the first video as well. Although if you're just interested in the technical aspect of this project, this is the video for you. I'd like this video to be as short as possible, so I'll get right in. The first thing I'd like to highlight is that while you might learn this briefly in passing in some introductory programming classes like those that would teach you Java, using constants is actually a very important idiom, and as you can see, I use it a lot in this project. Here's the constants that pertain to this particular part. The constants for positioning the various GUI elements. But here are some past constants that I've been using. The colors for the globe and for the stars, and here more recently for the GUI. And then I have some other miscellaneous constants that pertain to how the program reads the data that I have and how the globe behaves. And these constants basically just help me centralize certain behaviors of my program so that when I want to change, say, how big a pixel renders on the screen, I would just go and change one of these values rather than trying to find that in my code. So it's really convenient, especially for long documents. Now, just because it's a short topic, I'd like to cover sounds. In the last video, you heard a few sounds that I used to highlight the user's use of the mouse, interacting with the globe, and with the GUI. It seems like there's a lot going on with the audio system in Unity that I don't fully understand, but I do know how to just play a given audio clip at a particular position. So what you want to do is when the program starts up, you want to load up your audio clips using this method. Now, what resources.load does is it enters your resources folder in your assets folder of your project, which you can find in your Unity project just in this sidebar of the project tab. And under resources, you can put all your text files and audio files, and you can even put the graphics and whatnot. So I have 3 audio files here that I would like to load into the game: hover, select, and stapler. So here I just type the name in as it is, and I have to load it as an audio clip because I think it could return a lot of different objects. And so you want to make sure the program knows that this has to be an audio clip. If it doesn't return an audio clip, I believe this statement would cause an error. But that's how you load the audio clips in, and then when you use them, like right here, you just say audio source.play clip at point, and then you want to pass in the clip that you want to play, and then the vector 3 position where you want to play the clip. Usually doesn't matter where you play the clip. In fact, if you just wanted to play the clip without caring about like what side of the stereo you play it at, you could just use transform.position, which would just get the position of the camera. So you would just be playing the clip as if it were right inside your head. But if you take the position of an object as the position to play the clip at, then depending on where the object is in the world space, it will play the sound in like one or the other ears of your headphones, if you have headphones, or if you have a stereo sound system, it might play it in a particular spot. That's just kind of how the Unity engine handles audio. So here you see in my own code, I have if update hover returns true, which basically means that the mouse has hovered over something new that that I would want to play a sound on. Then I do various logic to determine which object I want to play the sound at. One thing that I found extremely important throughout this project, which seems to be a unique part of Unity that you just have to get used to, is to get references to all these components and game objects that I'm calling methods on and passing to methods and modifying. You usually need to call getComponent on something, and often that would be this.getComponents. So for instance, in this case, I'm trying to get the rect transforms under the two canvases that I've built, one for that little info box in the bottom right corner, and then for the locality info list, and store these in global variables that I will later use quite often, basically to specify their position, to be able to activate and deactivate these GUI elements. As I demonstrated earlier, I only display these canvases when the user actually does something like select a tile. So basically what I've done is I'm getting the components in the children of the main camera object, which is this, and I want them to be of type canvas. So basically Unity is going to search through the children of the camera and return an array of canvas objects. So if we go to the structure, the hierarchy of my program, you can see that here's the main camera, and then there are two canvas objects under it. So it's going to find these two and put them in that array. And it puts them in the array in the order that they appear in this hierarchy. So order is actually quite important here. This is why I'm okay with doing something ambiguous as saying that the zero index of the canvas contains the info canvas. It will always contain the info canvas as long as I keep this info canvas as the first element in this hierarchy. Of course, in some projects that may be very likely to change, especially if you're working in very big projects, in large teams. But I figure in my case, since I'm doing such a small project, and the overall structure of the GUI is not very likely to change, the only likely thing to change about the GUI is the actual appearance. I'm okay with just assuming that the zeroth element in this array will be the info canvas, at least for now. This get component idiom is just all across my project. Here I'm finding all the buttons in the locality list so that I can add them to my own list of buttons that I will later iterate over to find out if the mouse is hovering over them. Here's the logic for determining when the user is hovering their mouse over a button. The important part about figuring out if the mouse is inside uh, a particular object is to get some rect object that you can call the contains method on. If you can call the contains method on it, then you can pass it the position of the mouse and it will pretty reliably tell you if the mouse is in that rect. Of course, rect is short for rectangle here. And the way I'm getting this rect is by calling my own method that I made called getWorldRect on a rect transform, which is a component of all GUI elements. So for turning the rect transform into a usable rectangle that represents a rectangle in the world space, the only reliable piece of information I could get is get world corners, which will return all the points that make up the rectangle that the rect transform describes. So basically we create an array of 4 vector 3s to store the points in, and then we call get world corners on that array, and then we use those corners to construct our own rectangle. Basically, this is the top left corner, and then this describes its width and height. So to get the width that we need for the rectangle, we take the x-coordinate of the top right corner and subtract it with the x-coordinate of the bottom left corner. And then for the height, we take the y-coordinate of the bottom left corner and subtract it by the y-coordinate of the top left corner. So that's how we would convert the transform of a GUI object into a world space rectangle that we can use to determine whether the mouse is hovering over a particular button. So back here we're figuring out if the world rectangle that describes this button contains the position of the mouse. Also, as you see here, there does require some conversion of the mouse position as well. Input.mouse position gives you a screen point, but you need to convert that to the world point to be able to interact with this getWorldRect rectangle. And then, of course, this is my own behavior that I'm putting here. But I'm basically storing in a global variable this thing that is being hovered over so that when the user clicks the mouse button down, I can figure out if the hover isn't on any one of those buttons, and if it is, then we'll click that button and do some behavior with it. Also, something I never showed you, but I use very extensively since I use so much data in this project, is the text assets. As you probably saw before, I have lots of text files in my resources folder of my project, and these all contain the data that I need to load up the globe to look like Earth, basically, and have all the right names for places and localities and whatnot. So basically, I just use the same idiom that I used for the audio clips, except I load them as text assets. And then text assets have an element called text, which just gives back all the text in the text file. And then I just split them by new line because that's how I split up my data into an array of strings, and then I can load them into my two-dimensional arrays to fit to the globe of 10,000 elements. And then I have the resource files for the texture of all the globe tiles and this would be the texture for the sun. Just a circle for now. I might change it, probably will. And I will probably have another texture for the stars, so that they're not just squares. Now let's finally get into how I programmatically construct GUI elements. You may have noticed that in the scene view of my project, my locality quick info list does not start out populated with list items. So I populate it myself using script. It's a very long process, as you can see. It takes a lot of lines of code, which is kind of funny, but when you think about it, there's a lot of stuff that goes into determining how a game object is rendered, how it's positioned and sized and whatnot. So on each of these, I will add a rect transform component, a canvas renderer component, and either an image component or a text component. And then on each one of them, I have to set the parent so that the object gets put in the hierarchy somewhere. If you don't set the parents, it will just leave this object at the top of the hierarchy, which is not really what we want. I also have to set its position in the hierarchy, because canvases are actually a little weird. They don't render objects inside the canvas in front of one another based on their Z position. The Z position actually doesn't do much. What matters is whether an object is higher up in the hierarchy. The higher up an object is in the hierarchy, the lower on the stack it will render. So if we look at this canvas and we see, oh, there's a button and then there's a couple panes. And basically this button will render behind everything, and then this title pane will render in front of the button, but behind the info pane. And then this info pane will render in front of everything. So the reason I set all these items as the first sibling is because I want all these locality quick info items to render behind everything else that's in the canvas. Namely, these buttons. I want the items in this list to go behind these buttons so that it looks like they're more inside the list, I guess. The last thing here is probably the how you position the item and how you size it. So this anchor max and anchor min is exactly like we saw over here with the anchors. This exactly corresponds here. So you can use it to programmatically create these anchor presets. So if you just set some of these anchor presets on an object and look at the anchor values, you will be able to replicate that in your code. And then offset min and max, I'm not entirely sure what these are, but I think some aspects of them correspond with these values. The left, right, top, and bottom values, or in some cases this height and position Y and such. But usually you want to set these to 0 because I think the default values are very strange. So I set the X value to 0, but I keep this offset the same because for this particular object the height is important. And so I don't want to mess with that offset min and max. The Y value, that is. Because what we're doing is set size with current anchors. This is a bit of a strange method, but it's the only one that I could find to reliably change the size of a particular object. So basically, you can specify either rect transform.axis.vertical or .horizontal in this place, and that just tells the method it's going to change either the height or the width of the object. And then you pass a float. There is anchored position as well, is quite useful. It will correspond with position Y or position X, depending on how your object is anchored. I believe if it's anchored with just left, right, top, and bottom here in these words, then anchored position will not actually do anything. But like this is anchored at a point in the middle of the top side of this canvas, and so it actually allows you to change the position of either direction here. So anchored position would actually be quite important for this object. And when you create a text component, you want to make sure to change the font to Arial. Arial is just a variable that I have defined. It's a font object that you just have to, right from the start, get built-in resource. And it's a bit of a shoddy fix, but that's the only way I've found so far to load up the built-in Arial font. Later on, of course, I'll try to find my own font or design my own font, and this will no longer be necessary. It will probably be the same resources.load as the other string resources and audio clip resources and whatnot. So you want to change the font to Arial, because if you don't specify a font here, it will actually just leave it as no font, which will not render at all, which can actually be pretty puzzling until you figure out that there's no font set. And then you want the font size, unless you wanted the default 14-point font size, I think it is. And then of course the color of the text. And that's basically how you build objects. Speaking of the anchored position from earlier, I always set the anchored position to change the position of the list items as they appear in the list, so I can make them go up and down based on how much you've scrolled in that list. Or I use it to change the position of the canvases so that they appear off screen or on screen, depending on which UI objects are supposed to be open. So here you see if anything is selected, if any tile on the globe is selected, then I change the anchored position of the info canvas to have this constant that I've defined before, which means that the canvas will be positioned on screen. This is the X component of the vector, which makes up the anchored position, and then I just reuse the previous Y anchored position, because I'm not actually sure what this would be, but it's probably 0, but no, it's not 0, it's some weird value, but I don't want to have to deal with that. That's something that I've set up on my own in the scene editor, but I don't want to have to deal with that anymore. But I do want to have to deal with this X coordinate, so I can position it on and off the screen. Thank you for bearing with this kind of unorganized video. I feel like a lot of elements of UI design are non-intuitive, and so I wanted to share as many little details with you as possible, so you wouldn't have to go through the same kind of research I did to figure out the more fiddly aspects of Unity.